Hello guys, let's continue with the third task in which we need to find limits of functions and sequences. Actually, it's not very difficult task, just you need to know the formulas and apply them correctly. So let's start with the first limit. In this case, we see that it is not a function, it's a sequence. So we will apply rules for sequences. So in this case, our first step is to simplify all these parts. So for this, we will just need to open the brackets. We will get 4n in the fourth power minus 3n squared divided by 2n squared plus 3. And let's see what is the highest power in the numerator. And we see that it is 4. And the highest power in the denominator is 2. So 4 is greater than 2. So we recall that for sequences, if the highest power of the numerator is greater than the power in the denominator, so this means our limit will be 0. So we just write 0 here. That's it, very easy. The second limit is a little bit more difficult, but still nothing extraordinary here. So limit n converges to infinity, 1 to n plus 1 multiplied by n plus 2 minus n minus 2. So the method for solving this task is like you need to multiply all this fraction by the opposite, how to say it, like opposite expression. And in this case, we will multiply our fraction by this, because here we have minus and here we will have plus. So why do we need to do it? So let's imagine you have a fraction like a minus b, something like 3, and if you multiply it by a plus b, you will get that a plus b will be in the numerator, and here you will have a minus b multiplied by a plus b. And it is a formula. If we multiply it, we'll get 3a squared minus b squared. And that's very useful in our case, because we have square roots here, and if we multiply it by the opposite expression, we will get the squares, and these squares will eliminate our square roots. So let's just multiply our fraction by square root of n plus 2 plus square root of n minus 2. So well, we will get the same in the numerator, just this number, and in the denominator we will get 2n plus 1 multiplied by so I will okay, I'll write the full thing first. So as I said, we have a formula in the bottom, and yeah, and converges to infinity and converges to infinity. In the bottom, we will have just two parts, and the second part will be n plus 2 minus n minus 2. And in the numerator, we have this. So now let's simplify our equation. N plus 2 n minus 2 to n plus 1, and here we get n minus n is 0, 2 plus 2 is 4. So our next step will be to divide by the highest power of numerator and denominator. So as we have square roots here, the highest power of the numerator and denominator is n in the power 1/2. And we will divide by it all our expression. So what we will get? Here we will get n plus 2 divided by n in the power of 1/2, or just square root, plus n minus 2 divided square root of by square root of n, 4 to n plus 1 divided by square root of n. And now let's simplify it even more. If we divide this by this, we will get 1 plus 2 divided by square root of n. 1 plus 2 divided by square root of n. If we divide this by this, we will get 1 minus 2 divided by square root of n. In the denominator, we will get 4 2, because we divide to n by n, plus 1 divided by n. And now let's see in more detail. So this thing converges to 0 because at the end converges to infinity, our denominator becomes bigger, and yes, it will be converging to 0. The same thing here, this part converges to 0. This part also converges to 0. So this means that this part converges to square root of 2, and the denominator converges to 4 square root of 2. So the final answer will be 2, 4 square root of 2, and 1, 2 square root of 2. So again, just to remember better, firstly we multiply by the opposite expression with square roots. We simplified our equation, expression, and then we divided by the highest power of the numerator and denominator, and then we just found what will be the final answer. So let's continue with the task 3C. So the first two tasks were about sequences, and 3C is about a function. So x converges to 0. Here we have this. Sine squared minus 1. So you can see that we have here different functions, but the hint is here, because we have that x is close to 0, and this means we can use these formulas about equivalent functions. So all we need to do is just to replace all these functions by the corresponding function with x. So firstly, let's look at our first part. So e in the power of x squared minus 1. So if we look at the formula, here it is in the 7th row, we see that this function is equivalent at 0 to the function x. So as we can see here, our argument is not x but x squared. So this argument we will use for the equivalent function. So is equivalent at 0 to x squared. Let's work with natural logarithm. 1 plus 2x squared. And now let's find the formula. It is here. Natural logarithm of 1 plus x is equal at 0 to x, is equivalent to x. So As you can see here, our argument is not just x, but all this part, 2x squared, and this part we will use in our equivalent function, 2x squared. So, cosine x squared minus 1. Let's look at the formula. We have here that cosine x minus 1 is equal to minus x squared divided by 2. And here, instead of x, we have just x squared, and it will be our argument for the equivalent function. And we just take x squared take it to the second power and divide by 2. So let's just replace all these functions by equivalent ones. So the first part is replaced by 4 in the second power. Oh, sorry, x in the second power. The second part is replaced by 2x squared. And this will be divided by x in the fourth power. So 2x in the fourth power divided by x in the fourth power. So as you remember, no, I think we'll use another logic here. So we just simplify it and get the final answer will be 2. Oh, sorry. Yes. Actually, I made a mistake in our formula here. The equivalent function is with minus. It's like minus x squared in the second power divided by 2. So here we'll have minus 2x in the fourth power minus minus x in the fourth power divided by 2, so we just multiplied by 2, and to get 4 x in the fourth power divided by minus x in the fourth power. So the answer will be minus 4. So let's discuss the task 3D. So limit x converges to pi sine x So what do we see here? We see some functions like sine x, and we want to replace it with some equivalent ones, but we have that x converges to pi, and this means we need to introduce a new variable, and that will converge to 0. So we could use our equivalent functions. So if we take x minus pi, it will converge to 0. So let's take the new variable t is equal to x minus pi, and in this case x will be equal to t plus pi. And now we need to rewrite our limit with respect to our new variable t. So here we have t. So let's write from the new x squared will be replaced by t plus pi in the second power. Instead of x, we will write t plus pi, or multiplied by t plus pi minus sine 2 multiplied by t plus pi yes, divided by instead of x, we will write t plus pi, and this minus pi and plus pi will give us 0. So here we will only have t left, and yes, this will be our new limit. So we know that function sine is a 2p periodic. This means that sine alpha plus 2 pi is equal to sine alpha. And this means if we open the brackets here, we will get 4 pi, and here we will get 2 pi. So we just can replace these functions by sine 4t and sine of 2t. And speaking about denominator, it will not change. Now let's recall the formula of difference of two sines. So sine A minus sine B is equal to 2 sine A minus B divided by 2 multiplied by cosine A plus B divided by 2. So here we need to simplify our part with signs. We take 40 plus 40 minus 2t divided by 2. It is 2t. Oh, sorry, it's just t. 2 divided by 2, 1. And about cosine, we'll get a plus b divided by 2. 4t plus 2t divided by 2. It will be 3t. Cosine 3t. And if you look at this part, if t is close to 0, then this part is close to p squared. And for this part, for the bottom part, we have a formula. It is 1 plus x in the power of alpha minus 1 will be equivalent to alpha x. So our alpha is 5, and instead of x we have t. So our answer here is 5t. So let's simplify our limit, and we will get y squared 2. Instead of sine, we will write just t as an equivalent function. And if t is close to 0, then the argument of cosine is close to 0, and the cosine is close to 1. And 5t in the bottom. So the final answer is 2 y squared divided by 5. So basically what we need to do in these cases just to replace our functions with equivalent ones. So I'll do it step by step. So let's start with the inner function. So let's start with this function. As you can see from the formula, tangent x is equivalent to x at 0, and in our case our argument is not x but x in the third power. So we will use it in our equivalent function. So now let's put this instead of tangent x in the third power, and let's look at arcsine of x in the third power. And again our formula says that it will be just equivalent to x. And again our argument is x in the third power, so it will be equivalent to x in the third power. So great, let's work with the denominator. Let's start with the inner function, sine 2x in the third power. Yes, here we have 2x in the third power as an argument, and we will use it in our equivalent function. So it is 2x in the third power And let's put 2x in the third power instead of sine, and arc tangent to x the third power, and again the argument is 2x in the third power, and here we just have, I see. So, well, let's just replace, and our limit will be the following. It will be here x in the third power divided by 2x in the third power, and the final answer is just 1 divided by 2. And the last limit for today, 3f, limit x converges to 2, natural logarithm sine x minus 2 divided by 1 minus e in the power of x minus 2 squared. And again, as we see, we have some functions like natural logarithm, exponent, sine, but we cannot use our equivalent functions now because x converges to 2. So we need to introduce a new variable. X minus 2 converges to 0, and we should take variable t as x minus 2. And x in our case will be t plus 2. And now let's rewrite our limit with respect to our new variable. So just instead of x, we will write t plus 2. T plus 2 minus 1 sine instead of x, t plus 2 minus 2 divided by 1 minus e in the power of t plus 2 minus 2 squared. So let's simplify. Oh, yes, the limit here t converges to 0. So natural logarithm 2 minus 1, 1 sine, and 2 minus 2 will be 0, so just t, 1 minus e in the power of t squared. So as you can see, we can use our equivalent functions, and that is great. Let's look at each function separately. So natural logarithm of t plus 1. So let's look at the formula. Natural logarithm of 1 plus x is equivalent to x. Our argument is x, and we will get x. And in our case, the argument is t, and we will get it in our equivalent function. Sine t is equal to 0. To t, and let's work with 1 minus e in the power of t. So as you can see, we have here the second power, but let's just work for simplicity with the first power. So let's look at the formula. So the formula is e in the power of x minus 1 at 0 is equivalent to x. So let's write it here. Minus 1 is equivalent to x. But our function is somehow different, so we need to change it in such a way that we can compute our equivalent function. So firstly, we need to have a positive sign before e. So let's take the minus out of brackets and change like the order of our arguments. And now you can see that this is very similar to this. Our argument here is x, and our argument here is t. So this means as an answer we will get t and minus before this. And let's replace our functions with equivalent ones. So instead of natural logarithm, we will write t. Instead of sine, we will write t as well, and we will get the second power. And here we have the second power, and we computed that for the first power it will be minus t, so we take minus t into the second power, and finally we get that. So our limit will be 0. So that's it for the third task.